Lesson 3.2, Complex Numbers. How do you define and use the imaginary unit I? You had 3 problems assigned for independent practice. Let's go ahead and take a look at these. Problem number 6. We had negative I being multiplied to the entire parenthesis. So negative I times a negative 2 is a positive 2I. Negative I times a positive 10I is a negative 10I squared. Now I squares can be simplified as negative 1. So this is a 2I minus 10. That 10 is being multiplied to a negative 1. So I have 2I minus 10 times a negative 1 is a plus 10. We cannot combine any further, but they want the real to be written first and the imaginary to be written second. So 10 plus 2I is our final answer. Problem number 8. I have a binomial being multiplied to a binomial, so I'm going to go ahead and use my area model. 2 minus 4I minus 5 minus 3. This square is 2 times a negative 5, which is a negative 10. This square is 2 times negative 3I, which is a negative 6I. This square is a negative 5 times a negative 4I, which is a 20I. This square is negative 3I times negative 4I, which is a 12I squared. But you know that you can simplify the I squared to be a negative 1. So this is a 12 times a negative 1, which gives me a negative 12. So this square simplifies down to negative 12. My final answer for distributing all of these is the sum of these squares. So negative 10 minus 6I plus 20I minus 12. Combining like terms, imaginaries go with imaginaries and reals go with reals. So they want the real part written first. So negative 10 minus 12 is a minus 22. Now the imaginaries, negative 6I plus 20 I's gives me a positive 14 I's. Last problem, problem number 10. You have these two being multiplied together, and then they want us to subtract this one. We've been doing area model lately. Let's go ahead and solve this one with the distributive property so you can see both methods. So 1 times 9 is a 9. 1 times 3I is a positive 3I. 7I times 9 is a positive 63I. 7I times 3I is a positive 21I squared. So we just multiplied all of that. If you chose to use the area model, all of this would have been the inside of the area model. Now I need to subtract the 4, and I need to subtract the 2I. Now let me go ahead and show you. If we had done the area model to this, 1, 7I, 9, 3I. 9 times 1 is 9, 9. 1 times 3I is 3I, 3I. 9 times 7I is a 63I, 63I. 3I times 7I is a 21I squared, 21I squared. So you could have solved this using the area model, or you could have solved it through using the distributive property. So now I need to do my imaginaries plus my imaginaries. I's all go together. I squares stay with only I squares, so we need to deal with him in a minute. So 9 minus 4 is a 5. 3I plus 63I minus 2I gives me a plus 64I. Now I need to deal with the plus 21I squared. I squared, we know, simplifies down to negative 1. So this is 5 plus 64I plus 21 times that negative 1. So this is 5 plus 64I. 21 times a negative 1 is a minus 21. Real goes with real, so I end up having a negative 16 plus 64I.